All right, so chapter 6 is going to go over exponential and logarithmic functions. So we're going to start with exponential first. So an exponential function is a function where the base is a constant. So where the base is a constant and the exponent is a variable. And the exponent is a variable. So usually we're used to seeing it differently. We're used to seeing the base as the variable and the exponent as a number. The graph of an exponential function has an asymptote, which is a line that the graph of the function approaches, but it never crosses. So you have two types of functions here. Scenario 1 is where you have f of x equals b raised to the x power, where b, the base, is greater than 1. And you sort of have the upwards trend, which means that you are increasing. Option 2 is if you have the same function, b to the x, but now your b value is a fraction. It is between 0 and 1. So that's going to sort of give off the decay or the decreasing approach in terms of your graph. So we're going to graph each exponential function. We're going to state the domain and range. Okay, so what I would suggest doing is making yourself, you can certainly make yourself a little chart. I'm going to try and make my answer, say, equal to something nice and easy. So I'm going to sub 0 in first. And if that's 4 to the 0, well, that's equal to 1. So I have the point 0, 1. If I take negative 1 and I sub in negative 1, that's 4 to the negative 1, which is 1/4. If I take negative 2 and I sub in negative 2, that gets me 1/16. So I'm getting fractions that are smaller and smaller. Whereas if I go on the other side, if I sub 1 in, I get 4 to the first, which is 4. And if I sub 2 in, I get 4 to the second, which is 16. So 1 is going to get me 1, 2, 3, 4. And then 2 would get me 16. And then the other guys are going to get me very small decimals. Okay, but what you are going to find is as you keep going down in terms of the x's with your negatives, you're going to get closer and closer to 0, but you're never going to actually touch 0. It's going to get to be a smaller and smaller decimal, but it's never going to actually reach 0. So according to this graph, this is giving off the growth appearance because it's increasing. Our domain, what x values apply? Well, that would be all of them. So negative infinity to positive infinity. For the range, basically, you're going anywhere above 0. So from 0 to infinity, it doesn't equal 0, so you have a parentheses, and it doesn't equal infinity, so you have a parentheses as well. And then just for clarification here, we have a y-intercept. Where did it cross the y-axis? At 0, 1. Just to try to gather as much information as possible. So B is the same thing. So I'm going to take, again, make a chart. Since it's the same type of thing, I'm going to start with the same thing. So 0 is going to get me 1. Negative 1 will get me 1/2. Negative 2 will get me 1/4. Positive 1 will get me 2. Positive 2 will get me 4. So I have my points here. 1, 2, 2, 3, 4. And again, you have the same appearance. So this is still a growth scenario. The domain is still going to be all of the x's, so negative infinity to positive infinity. The range is anything from 0 to positive infinity. And the y-intercept is going to stay at 0, 1. Okay, so A and B are very similar to each other. Same problem, it's just the base changed. So now with the next set of examples, now we flip into fractions as our base. So what I'm going to do is keep going with the same direction that I was going in before. I'm going to still sub 0 in. So 1/3 to the 0 is 1. If I sub negative 1 in, well, that's 1/3 to the negative 1, which is going to flip that fraction and make it 3/1 to the first, which is 3. If I sub negative 2 in, that's 1/3 to the negative 2, which is 3/1 now to the second, which is 9. If I sub positive 1 in, then that's going to be 1/3 to the first, which is 1/3. If I sub positive 2 in, then that's going to be 1/9. So I have 0, 1. Negative 2 gets me 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1 gets me 3. And now what I'm going to find is a very similar idea, just going in the opposite direction. Okay, which would then mean this is a decay situation because it's coming down. The x values are not changing, so it's still negative infinity to positive infinity for the domain. The range is still going to be from 0 up, so from 0 to infinity. And the y-intercept is still remaining 0, 1 for this. It's just the direction of the graph has shifted locations. And what you're going to find is you're going to find the same thing for the next one. You're going to get 0, 1. If you were to make yourself a chart, you're going to get negative 1, 2, negative 2, 4. And the other guys are going to be decimals down here. And the same exact information is going to hold true. It's still going to be decay. Domain is still going to be negative infinity to positive. Range is still going to be 0 to infinity. And your y-intercept is still going to be 0, 1. Because again, all you're dealing with is a base raised to the variable power. Nothing has been changed or added to the equation. But there's lots of types of transformations can occur, and that's where these last 4 are going to come from. So a typical exponential function has more of a formal format here. So it should be f of x equals a times b to the x minus h power plus k. So there's a lot more components that go into it. H is your horizontal translation, how far left or right you're going. And it is typically the opposite of what you think. Okay, so if you see, maybe make a little note, opposite of what you think. So if you see a minus 3, you're really going right 3. If you see a plus 3, you're really going left 3. K gives you the vertical, so are you going up or down? And it goes with the sign. So if it's positive, you go up. If it's negative, you go down. The value in the A value will determine whether you're reflecting something basically if you're reflecting something. And then just keep in mind for the B, if B is greater than 1, that should give off the growth appearance. So it typically starts going this way. But if B is between 0 and 1, that gives off the decay appearance. So it should be coming down, just to help you in terms of the reflection process. All right, so let's see here. Now, in terms of horizontal translation, these are also your x values. The vertical translation, these are your y values. And your asymptote, where you can't cross, is going to be y equals k. And then in terms of determining your flipping and stuff like that, that's going to deal with your y values as well in terms of a reflection. So these are a little bit more involved because there's a lot more going on. So let's take one step at a time. So we're going to still try and make a chart. Okay, so I have x and now I have g of x or y. But in the past, we've always just subbed in 0. You certainly can sub in 0. Just be careful though. When you sub in 0, that's 2 to the 0 plus 3 minus 5. Every other time we've just written 1. But in this case, 0 plus 3 is 3. And then we get 2 to the 3rd minus 5. Well, 2 to the 3rd is 8. And 8 minus 5 is 3. So this is actually 0, 3. If you choose positive 1 and sub it in, you get 2 to the 4th, which is 16. And 16 minus 5 is 11. If you say choose negative 1 and plug that in, you get 2 to the 2nd, which is 4, and 4 minus 5 is negative 1. If you get negative 2 and sub that in, you should get a y value of negative 3. And then I know that if I go higher in terms of x values, it's just going to snowball. It's going to just jump super far ahead. So I'm going to actually pick another negative value. I'm going to go with negative 3. And then if I sub that in, negative 3 plus 3 is 0. 2 to the 0 is 1. And 1 minus 5 gets me negative 4. So that gives me some points to work with. So now I've got 0, 3. I've got negative 1, negative 1. I've got negative 2, 1, 2, 3. I've got negative 3, negative 4. And I've got 1, 11, which probably puts me somewhere up here. Okay, now what you want to also keep in mind, other important bits of information. We have an asymptote, which we said was y equals the k value. Well, the k value in this case is what's being added or subtracted, so that's y equals -5. So if we come down here to -5, we're going to make ourselves a dotted line because the graph should never cross that particular line. Now, according to the way our movement is going to go, transformation-wise, you see this x plus 3? Well, that x plus 3 means that we're going left 3 from the original y-intercept that we would typically deal with. And then this -5 tells me I'm going to go down 5. Again, from the original y-intercept, which has always been 0, 1. But if you make your chart, you're going to get that same idea. So I'm just going to sketch going this way. Okay, and the point now, my new point down here is now going to be -3, -4. And if you checked that from where the old y-intercept was, which was 0, 1, and if you go left 3, down 5, you're going to find you end up in the same spot with -3, -4. Now for domain and range, domain, still all the x values apply, but in terms of the range, your asymptote has changed. So we can't cross -5, so now we're going from -5 up, and they both get parentheses with them. And in terms of the way our graph looks, this would be a growth scenario with our points. All right, let's do, so that one, there was no A added to it, but everything else was added there. Everybody else has an A. All right, so let's go down to C first. So again, make your chart if it's helpful to you to come up with points. Say I want to start with 0. If I plug 0 in, I get 1/2, 3, 0 plus 4 minus 5. That's 3 to the 4th, which gets me 81. Half of 81 minus 5 is going to give me a huge number of 35.5. And then if you use, or if you plug in these other values, these are some of the other points that you potentially could get. -4. Okay. Now, in terms of looking at it, the B value is still, B is equal to 3, which is still greater than 1. So I'm still going to have the growth appearance. Plus the A value is equal to 1/2, which is positive. So nothing's changing there. There's no reflection. But according to what my transformations tell me, I've got x plus 4. So x plus 4 means I'm going left 4 from the original y-intercept. And this -5 again is telling me I'm going to go down 5. So according to where I was, if it's too hard with all these random decimal points, think, if originally we were starting at 0, 1, well, now we're going left 4. So 1, 2, 3, 4, and then we're going to go down 5. 1, 2, 3, 4, 5. So my new point should be -4, 1, 2, 3, 4, -4. And my asymptote, remember, is y equals k, which again, k in this case is -5. So I have a vertical asymptote, or a horizontal asymptote, sorry, at y equals 5, -5. And then because we said it's a growth appearance, we should be giving off the growth visual in terms of our graph. It should be going up from left to right. All right. All right, let's see. So now let's actually go to D, because that's similar as well. So again, make yourself a chart. In this case, maybe it makes sense to get one particular point, which if you plug in x equals 0, plug in x equals 0. If you were to do that, you get 5 to the 1/2 to the 0 minus 8. This is 1, and you get -3. So you have the point 0, -3 to work with. 1, 2, 3. Now, according to our transformations, x means no shift, left or right, L or R, because it's just x. But this negative 8 is now going to say I'm going to go down 8. Okay? Not only that, but that's also indicating to me what my asymptote is. So I have an asymptote at y equals negative 8. So 3, 4, 5, 6, 7, 8. So I have a horizontal asymptote at y equals negative 8. Okay, so the other bit of information, b is equal to 1/2. And 1/2 is between 0 and 1. The a value is 5, which is still positive, but this is a decay appearance. So I have the point 0, -3 here. And I know I need to be coming down because I have the decay type of graph going on. I already wrote that up there. Okay. Now, in terms of, oh, I didn't do domain and range for the last one. I got to do that. So domain and range, all the x's still apply. Range, it would be everything from -8 up. Oops, -8. The last one, just because I forgot to do that, domain is still the same. And then the range would be from everything -5 up for that. All right, one final one here. We've got lots of information. So we're going with a reflection because we have -4. So reflect over the x-axis. That's what the -4 does. The x -1 tells me I'm going to go right 1. The +2 tells me I'm going to go up 2. And let's say if I wanted to find a specific point there, what I could do is I want to make that exponent 0. So make exponent equal to 0. So I'm going to plug in x equals 1. So if I do that, I get -4 times 1/2 to the 1 minus 1 plus 2. Well, this is 0, just 1, and -4 plus 2 gets me -2. So I have the point 1, -2. 1, -2. Okay, my asymptote is y equals k, which is y equals 2. So I'm going to come up here, y equals 2, and draw my asymptote. Now, typically, because the 1/2 is my b value, that would be a decay situation. So typically my graph would go this way, but keep in mind, we have already said that there is a reflection going on. So you need to reflect that entire graph over the x-axis, which means that our graph is now going to actually look like this. Originally, it would have been the flip of it because it's a decay situation, but it's now going to take on the growth appearance because of the way that you have to reflect it over the axis. Okay, and it's got to come all the way up there to that dotted line because that is where the asymptote is. And this important point right here would be 1, -2 for that. So the domain still not changing, but now with the range, keep in mind, it's from +2 down. So you can't write 2 to -infinity. That's not written correctly. So you have to go -infinity to 2, and they both get parentheses on it.